Janamni.
Good morning, students.
Good morning, sir.
Good morning, ma.
Good morning, sir.
Good morning, very good morning, all of you. Good morning. So the last class we discussed about that one in the basic concept of the organic chemistry. We discussed the hybridization and also we discussed about the nomenclature of organic compounds, particularly IUPAC nomenclature. What are the rules are present? How to nomenclature a given unknown organic compound? We are identified in the basis of the that is the root word, primary suffix, secondary suffix, and also prefix. And also to frame the rules, select the longest chain, and also select the least, that is a substituent must be present in the least number carbon atom, and also write in the alphabetical order. If the functional group is there, give the priority to the functional group, which must be included in the longest chain only. On the basis of that rules, you have to write the nomenclature, that is the IUPAC nomenclature. Then after we are discussed about the isomerism, in that some of the students are raised that one some questions. I will clarify here only. So the isomerism already I told that it is a same equal parts, that is the isos and mers. Same molecular formula but different structural formulas. It's called as isomers. The isomers are broadly classified into structural and stereoisomers. Structural means the arrangement of the carbon atom is differ. Structural means arrangement of the carbon atom is differing. Stereo means the same structure, but the orientation of the carbon atom is different. Orientation, the definition of the stereoisomers is same structural formula, but differing the orientation of the atoms or groups. Means, sir, already I told that one carbon atom is fixed. Next second carbon atom, it will be rotated to the 180 degrees. The rotation will be takes place. This is called the orientation of the atoms. The orientation, same structural formula, but differ in the orientation of atoms or groups is called as stereoisomers. So in the structural isomers, we are having of chain, positional, and also functional isomers. Chain means chain is differing in the straight chain. Position means position of the functional group is differing. In the first position is there, next isomer is having of second position, like the third position, if it is a possibility is there. Like that the position of the isomers, that is a functional group is changes, it is called as a positional isomer. Functional means functional group itself is changing, that is called as a functional isomers. Coming to the stereo, already stereo size means same structural formula, same molecular formula, same structural formula, but differ in the orientation. Differing in the orientation, that is called as a stereoisomers. In that we are having the geometrical and optical. Geometrical isomers also called as cis-trans isomers. Cis means the same on the plane, the functional group or a one substituent is present, that is called as a cis isomer. If oppositely, diagonally opposite is present, those isomers are functional groups or whatever the substituent you are considered, that is called as a trans isomer. Opposite diagonal is there, it is called as a trans. Same on the plane, above or below, those are called as a cis isomers. That means geometrical isomers is possible only in alkenes, unsaturated alkene. That means double bond carbon atom only that can exist. Geometrical cis trans isomers. That's why I given a skeleton formula. If any formula is given to the right, the geometrical isomer means first the skeleton formula is C double bond C, and 4 bonds are present on the each carbon atom. You can select whatever the given in the compound. You can select it and write it as a one type is the above the plane. One is the carbon atom is rotated to 180 degrees. You are getting of this is called as a rotation. Okay, so polarization will take place. You are getting of the trans formula. Similar way, optical isomer means it is nothing but the mirror image. I given the chloro, fluoro, bromo, iodo, methane is given. If you are having the lactic acid is there, the lactic acid is COOH and CHCOH, CH3. It is a formula is there. From that, this is a formula of optica, that is lactic acid. This is the lactic acid. Mirror image means you are rotating this carbon and second carbon atom is rotated so that you are getting off 180 degrees. You are getting here the carbon atom. That means this is the carbon atom which is present and COOH. This means sorry, it is a COOH. Right? If you want this means right or that only, that is a COOH. This is, and the next is the, this is a mirror image. This is a lactic acid. So this OH is a left side, this is a right side will be there. Then like that, this is called as the optical isomers. This is about the, you are learning about the last class about the isomers. Now I'm going to the second unit. In the second unit, you are having of the unit 2 is alkanes. Once again, I'm repeating that one. In the examination, what question is asked? Please remember that one. You have to write that answer only. From this chapter, so many in the organic part, they are asking for one question means you are asking for another, writing for another question. Write the preparation of alkane means you are writing the alkenes preparation. Write the preparation of alkenes and its property means you are writing the cycloalkane. Last time this is an annual examination. That is an annual, not semi exam, second year. The question is, the fourth question is asked, write the preparation and properties of cycloalkanes. The question is asked for the 15 marks question. But the most of the students are written as preparation of alkanes. If you are writing the properly, one step by step completely, but we are giving only 0 marks. Yeah, the question is only the cycloalkanes you have to write, not the alkanes. Please remember in the organic part. Don't confuse what question is that is asked in the examination. That question only you have to write it. Okay, coming to the alkanes. Alkanes, already I know that given the structural form that is in the classification of the organic compounds, the alkanes are saturated hydrocarbons. Saturated hydrocarbon means it is a single bond, covalent bond is present on each carbon atom. It is a saturated one. All are single covalent bonds are present. It is a saturated hydrocarbons. The general formula of alkenes are CnH2n plus 2. CnH2n plus 2. These are the general formula. Is the unsaturated hydrocarbons. Sorry, saturated hydrocarbons. Saturated hydrocarbon means they are combined. That means this carbon atom is attached with the 4 single covalent bond. These 4 single covalent bonds are very stable. Suppose any reaction, chemical reaction or any reagent you are reacted this one, this does not react anything. Under ordinary condition, alkanes do not react with any chemical reagent in the laboratory. Why? Because these are the saturated hydrocarbons consisting of single covalent bonds. That's why this alkanes also called as paraffins. It's also called as paraffins. Our examination point of view, it is very important. Paraffins means it is a Latin word. Again, para means little. Para means little. Affins means affinity. Little affinity is made. They do not undergo any chemical reaction. Why? Because of saturated. All covalent bond, single bond lead. This you have to break the single bond means it will be requiring of large amount of energy is required. So that it is a stable compounds. So that's why they do not undergo any chemical reaction. But under drastic condition, drastic means some specular cases. This can undergoing of reaction, chemical reactions only. That's why the alkanes also called as paraffins. Please friend, this is a general formula is important. It is also alkanes also called as a paraffins. Why is the Latin word? Para means little. Affins means affinity. They do not react with it. This is a little affinity is only present in particularly alkanes. Now, what are the sources of alkane? How they are obtained in the nature? Mainly the sources of alkanes are petroleum products and natural gas. So under the earth only you are extracting from that. That means from the petroleum products and also as well as the natural gas. Natural gas means consisting of your LPG gas. LPG gas cylinder is consisting of which gas? Propane and butane. So methane and ethane is not there, but the propane, butane is major constant is present in the your LPG gas cylinder, which is used for the household purpose. Okay. So friends, if you are remember that one, these are gases 1 to 4 are gases only. Then after you are having of the octane fuel is there. If you go to the any petrol bunk, a signboard is there, octane fuel. Octane fuel means is a petrol. Octane means 8 carbon atoms are present in the petrol. If you take the diesel means it's consisting of C14. The C14 is present. If you want the kerosene means it is nothing but C20. Number of carbons are more. That's why you are getting of smoke. Carbon atoms are increases in the natural. Whatever the gases, you are increasing of the carbon atom means the smoke will be coming out. That's why here these are the main sources are the petroleum products as well as the natural gases. So this is about the main important of the alkanes story. And coming to the preparations. Now, how to prepare in examination? Write the general methods of the preparation of alkanes and its properties. They will ask for the 15 marks question. Sorry, you are a 10 marks question. For the year wise, it is a 15. Now your essay type is it is a 10 marks question. So the 10 marks question means you have to write the preparation means some of the preparation as well as the what are the properties are involved in this particular alkanes or all whatever it may be. Okay, you have to write it. So first is the we are going to the preparations. So friend, first is hydrogenation. Hydrogenation means what? Adding of hydrogen is called as hydrogenation. Simply, adding of hydrogen is called as hydrogenation. I am using of simple formula for this hydrogenation. The chemical that is particular preparation. This particular equation will be useful in the alkenes also, alkynes also. That is the important of this one particular hydrogenation. What is hydrogen means? Adding of hydrogen. For what? Unsaturated hydrocarbon. I'm taking the very unsaturated hydrocarbon. That is the general formula is CnH2n minus 2. This is a general formula for what? Alkynes. Alkyne. YNE. Alkyne. When you are added, what you are added? Hydrogen in presence of a catalyst, nickel or platinum. We are taking. If you are taking the nickel means it requiring of 200 degrees Celsius temperature is required. Okay, so friends, here I am adding the unsaturated hydrocarbon is added to the hydrogen. Formation of what? Simply you are getting of CnH2n. Just H2 means here we are adding the plus 2 minus 2 is cancelled. We are getting of CnH2n. It is called as alkene. So why I mean this is a very important is in the preparation of alkene also it is one of the preparation method. In that also you can use this particular one preparation method for the alkenes also. This alkene again further hydrogenated in presence of nickel catalyst and the temperature. Okay, then you are getting of the CnH2n plus 2. This is the alkane. See friends, here getting of this particular equation. Very simple equation. Once you remember means you can, this is a fixed one, you are getting of one preparation is over. Why? Because in the general method of preparation, at least you have to write 3 preparations, at least. In that one is, this is one, it is a repeated one in the alkenes as well as the alkynes also in the properties. Okay, this is the one. In that particular, you can take the one example. I am taking up one example is C2H2. This is the acetylene. That means ethine. IUPAC name is ethine. Okay. This ethine is hydrogenated in presence of nickel catalyst. Whatever the formation of C2H4, it is nothing but ethylene. Ethylene is the general name, but it is the IUPAC name is ethene. See, just add the hydrogens. Now again I am adding of hydrogen plus, this is the plus, you can do it in presence of nickel. So you are getting of C2H6. C2H6 means it is nothing but ethane. Ethane is the alkanes. Okay, here the alkanes we are using of the alk is the root word, ane is the primary suffix. So if the one carbon is there, means we are writing up it is the methane. If 2 carbon, it is called as a ethane. If 3 carbon, it is nothing but propane. C4H10, it is a butane. Okay, friends. Like that, you are reading this writing of the Alkane series. These are the number of series are present. And in this also, if you see the first family of this particular Alkane series is a methane. Second is the C2H6 is a ethane. This difference is how much? 1 carbon atom, 2 hydrogen atom. 1 carbon atom, 2 hydrogen atom is differ. That series is called as, that particular name is called as homologous. Homologous. These are also ethane and propane. The difference is 1 carbon atom, 2 hydrogen atoms. And propane and butane is also differ by the 1 carbon and 2 hydrogen atom. This series is called as homologous series. In the examination, they also asked the what are the homologous series. Alkanes are showing the homologous series also. Each consecutive means the consecutive members are differ by the 1 carbon and 2 hydrogen atom. So in this particularly first preparation, it is a hydrogenation. Hydrogenation means unsaturated hydrocarbon is hydrogenated in presence of nickel catalyst. You are getting of unsaturated, again you are getting of saturated hydrocarbon, that is a ethane. This is the first preparation. Very important preparation. Generally, you are having a very simple preparations. I will give the not complicated one. Why? Because in the book so many are there. I don't want all the things to confuse to you. So simple equation is hydrogenation. Okay. So friends, next we will go to the second preparation. The second preparation is the name reaction. Name reaction, always remember, anywhere in the organic chemistry name reactions are present means it is very, very, very important. Either in the long question or a short bit they will ask. Separately they ask the name reactions. Here this is the Woods reaction. Woods reaction. What is Woods reaction? Again it will be asking in the separate question as a 5 marks bit. Short question. What is Woods reaction? So let us see the what is the theory, what is the Woods reaction mean. When alkyl halide, again the problem is alkyl halide means are what? See, I will give the example. This RH is called as alkane. Alk means R. Is H means ane, alkane. Okay, friends. So in this case, you are using of methyl hydrogen. This means it is called as a methane, CH4. It is nothing but CH4. Once you are removing this one from the methane, it is called as a methyl. Okay, you are removing the hydrogen, it is called as alkyl. I am removing what? I am removed only 1 hydrogen atom from the alkane, saturated hydrocarbon. I am removing 1 hydrogen. I am removing from the methane, it is called as a methyl. I am removing from the alkane, 1 hydrogen is removed, that is called as alkyl. So in the Woods reaction, alkyl halide. Halide means what? X is the halide. Halide means halogens. Either it may be a chlorine or a bromine. Sir, halogens are fluorine, chlorine, bromine, iodine, astatine, sir. Why you are taking only 2, sir? Means fluorine does not react. It react very fast reaction. Why? Because it is a very small size, high electronegativity atom in the periodic table, fluorine. The reaction is very, very, very super fast. So you can't determine the reaction. So that's why fluorine does not take place. You can't use. And also iodine. Iodine is very, 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 very slow reaction. Means suppose today you are reacted. After 5 days, that will be reaction takes place. So the determination step is not possible. That's why you can't do. Only the chlorine, bromine is the moderate one. And remaining others are astatine. Astatine is a radioactive element. You can't take the radioactive element. So only the thing in the halogen family, you can take the reaction purpose, only chlorine and bromine. That's why this is called as alkyl halide. X is called as alkyl halide. Now coming to our Woods reaction. What is the Woods reaction? Please remember, Woods reaction. What I say in the very first class, that means organic chemistry is a BG class. Why? Because your mathematics like that, 1 + 1 is 2, or A + B whole square, whatever you are using this principle. Here also Woods reaction. Alkyl halide is treated with the dry ether in presence of dry ether, and also treated with the sodium metal. 3 are there. What is alkyl halide is there? Reagent is a dry ether. It is act as a catalyst. What do you mean by the catalyst? Catalyst only increase the rate of the reaction, but does not participate in the chemical reaction. Please remember. Today you are here, drink that is a tea or coffee. Tea or coffee is a catalyst. That is not useful for your body. Just it will motivate your nervous system. Okay, friends. So tea or coffee or alcohol, these are the nothing but the catalyst only. They are not useful to our body. That means they are not producing even the proteins or vitamins or carbohydrate. Nothing is there. It is harmful to our body, but it is motivate our nervous system. It is called as a catalyst. Here also catalyst is motivate that fast reaction. Reaction takes place very fast. So in this case, particularly, we are using in the Woods reaction when alkyl halide is treated with that means in presence of dry ether, and also is treated with the sodium metal. This is called as alkyl halide. It is a pure sodium metal. When alkyl halide is treated with the sodium metal in presence of dry ether, formation of higher alkane means you are getting off. This is called as alkane. Also sodium halide. This is sodium halide is present. This is called as Woods reaction. Friends, here I am using the general reaction. If you take the example for better understanding purpose, instead of alkyl halide, I am taking off methyl. What is this? Methyl bromide. So one hydrogen is removed from the methane. It is called as a methyl. It is a methyl bromide. Is treated with the sodium metal in presence of dry ether. Formation of what? 2 higher compounds. That means CH3, CH3. Okay. Next, the byproduct is sodium bromide. It is sodium bromide is formed byproduct. What is the compound name? What is the compound name? So according to our nomenclature, number of carbon, root word is 2, means it is a saturated. Primary suffix is ane. One means it is a ethane. See friends, you are taken a methyl, single carbon. You are getting of double ethane. In this particular case, Woods reaction, we are getting double compounds, not single one. Not odd number of hydrocarbons are not prepared by means of Woods reaction. Odd number means 1, 3, 5, 7. You can't prepare. Only even numbered. One you have taken methyl means you are getting off ethane. If you are taken the ethyl group, you are getting off butane. So in the examination they will ask how to prepare N-butane. How to prepare N-butane from ethyl halide. Ethyl halide means C2H5. Ethyl halide. They are treated with it means nothing but it's a Woods reaction. Double is getting from the ethyl to butane. Double you are getting. Methyl to ethane. Propyl to hexane. So odd number does not given by this particular Woods reaction. This is called as a name reaction. Very, very, very important reaction in your examination point of view. I'm using of how many stars. I don't want to that one. All are stars. Everything. This is about the second reaction in the general method of the preparation. Now coming to the third method. Third method of the preparation. This is also name reaction. Third is Grignard reaction. Grignard reaction. So name reaction means again it is a important one. Star mark, keep as a star mark. It is a Grignard. What do you mean by the Grignard reaction? Again listen. Alkyl halide is treated with the magnesium metal in presence of dry ether. What is the difference between the previous example? That means Woods reaction. This one. Only the metal is differ. There a metal is the sodium. Here the metal is the magnesium only. The remaining other things, whatever the material, raw material is taken, so all are same only. In the Woods reaction, we are taking the alkyl halide. Here also we are taking the alkyl halide. This is alkyl halide. But the metal is we are taking here, magnesium is taken. Previously we are taken as sodium. And the whatever the catalyst you are using as dry ether. Here also using dry ether. So friends, here easy to remember the Grignard reaction. Alkyl halide is treated with the magnesium metal in presence of dry ether. Formation of alkyl magnesium halide RMgX. This is a very, very important formula. RMgX is called as Grignard reagent. This is called as Grignard reagent. RMgX is called as a Grignard reagent. So many times of this question in the your multiple choice question. What is the Grignard reagent? RMgX. This RMgX Grignard reagent on hydrolysis means we are adding of water. Formation of RH. RH means alkane. And byproduct magnesium hydroxide and halide. This is the byproduct which is obtained. Unstable product is obtained. Magnesium X is there, here OH is there, H is replaced here. So you are getting off alkane. See friends, here in the Woods reaction only you can getting off the even numbered carbon atom, higher number of alkanes. But here a single, that means odd number of hydrocarbons also you can prepare with the help of Grignard reaction. So Grignard reaction, that is the importance of the, you can take as anyone. If you want the, we are taking this is a methyl halide, you are getting off methane. Ethyl halide, you can getting off ethane. Propyl halide, you can propane. Butyl halide, butane. Pentyl halide, pentane, like that. Any number. But in the Woods reaction, only higher alkanes will be getting. Means starting 1 taken means you are getting off the byproduct is 2 twice. Starting 2 taken, you are getting the product is 4 times. 3 taken, 6. There is a carbon atoms are increases double. Every time double is increases. That is a Woods reaction. It is a Grignard reaction means nothing but alkyl halide is treated with the magnesium metal in presence of dry ether. Formation of alkyl magnesium halide. Alkyl magnesium halide. Alkyl magnesium halide is called as Grignard reagent. This Grignard reagent on hydrolysis you are getting of alkane. Let us say the example for this also. I am taking off methyl chloride. This is the methyl chloride. Previously I am taking the methyl bromide. I am changing the halogen group. Just methyl chloride in presence of magnesium metal in presence of dry ether. What do you get? What do you get? Methyl magnesium chloride. Methyl magnesium chloride is called as a Grignard reagent. This is methyl magnesium chloride. Methyl magnesium chloride. This on hydrolysis. The only one step I am writing. This on hydrolysis. You are getting off methane and magnesium hydroxychloride. Magnesium hydroxychloride is the byproduct is obtained. But the major compound is the methane only. Okay. Methane will, this is a simple example we can write in the Woods, there is a Grignard reaction. So here Grignard reaction is nothing but reagent is called as alkyl magnesium halide. Alkyl magnesium halide is called as a Grignard reagent. So this is about the Grignard reaction. That is the third reaction. Generally in the examination, write the general methods of the preparation of any alkanes or cycloalkanes or whatever. You can write minimum 3. Compulsory minimum 3. 3 is over. 1 is the hydrogenation is finished. Next is the Woods reaction is finished. Third is the Grignard reaction. One more reaction I can also add it to this preparation. That is the fourth preparation. The fourth preparation is called as Kolb's electrolysis. Kolb's electrolysis. Again, it is also very, very, very important. Why? Because it is also named reaction. Kolb is prepared this reaction. This is also why this is also very important one. What is the Kolb's reaction? So what is the electrolysis means? Already you know that the electrolysis means you are keeping up the two electrodes and adding up that means you are connected the electricity will be processed, means electrolysis. Aqueous solution here required. Aqueous solution will be particularly alkyl, that is the sodium fatty acids of the salts. Sodium fatty acids means we are getting up simple. I will give this one CH3CONA. It is called as sodium acetate. Why sodium acetate is called as a CH3COH is called as acetic acid. So instead of H, I am removing the H. In that place, I have occupied the sodium. So it is called as sodium acetate. This is also called as monocarboxylic acid, nothing but. Monocarboxylic acid salt. This is nothing but the salt we are using. So in the cold electrolysis, you are using of RCOOCNA. This is the sodium fatty acid. Sodium fatty acid salt. This is nothing but. Why? Because this is a fatty acid. It is a sodium fatty acid on hydrolysis. Hydrolysis means why? Because we require the aqueous solution, electrolysis. So due to the electrolysis, this will be dissociated into ions and the formation of alkane and carbon dioxide, water, okay, and also formation of sodium hydroxide. So friends, see here alkane, carbon dioxide, water, sodium hydroxide. This alkane and carbon dioxide at anode and water and sodium hydroxide at cathode. It will be formed during the electrolysis of cold electrolysis. That means during the cold electrolysis, whatever the sodium fatty acids and means monocarboxylic acid salts. Monocarboxylic acid salts are hydrolyzed. You are getting of simple alkanes. That means alkane. Monocarboxylic you are taken means it is a, suppose it is a R is a CH3 means you are getting of methane. If R is the ethyl, we are getting of ethane. Let us see the example for this particularly. This is nothing but sodium acetate. Sodium acetate. When sodium acetate is hydrolyzed during electrolysis, formation of CH4 means methane plus carbon dioxide plus sodium hydroxide. Okay, sodium hydroxide. Sorry, it is only hydrogen. Hydrogen is liberated out. Means carbon dioxide, hydrogen, as well as you are getting out from this particular preparation. Cold electrolysis. It's an extra method. You are using adding of one more method I added, but especially in the examination, they will ask the separate question as a 5 marks question. What is cold electrolysis? Give the equation. Cold electrolysis is nothing but monocarboxylic fatty acids are hydrolyzed. That means during electrolysis, you are getting off saturated hydrocarbons. That is the main concept of the cold process. So from the cold process, you are getting off alkanes. Whatever the alkanes you require, you can prepare from this cold electrolysis. This is about the 4 preparation, general methods of preparations of alkanes. Now coming to the physical properties. These particularly unsaturated hydrocarbons are very stable compounds. Why? Because it is a single covalent bond is there. They do not reacted, chemical reaction do not reacted with the reagent with ordinary temperature. Why? Because it is saturated already. So, but under drastic condition, they can undergo the substitute. That is a reaction will be takes place. Okay. In this particular case, this particular alkanes. Now the physical properties of alkane means C1 to C4. C1 to C4 means methane to butane. These are the gases in gaseous state. Next C5 to C14. These are the liquid states. And C15 to whatever the higher numbers greater than that one, it is in solid states. These are physical properties of that one. And particularly you can using of these alkanes are natural gas, that is a LPG gas. Those are consisting of all the gases. That means methane, ethane, propane, butane. But major constant is the propane and butane is present in our LPG gas. Okay, methane gas, it is a nothing but the particularly methane gas is a gobar gas is only produced. The gobar gas means by means of the cow dung. We are getting of the gas. That gas is called as a methane gas only. Purely methane gas is obtained by means of cow dung. Okay, so here the methane gas is very dangerous. In the any particularly, that means in particular the thicky place. That means it's a whatever the soil is making of it with the water is contaminated, that will be producing of the methane only. So the methane gas is a very dangerous one. If you are inhaling easily, the poisonous gas will be entered. That means our that means hemoglobin is consisting of oxygen. It immediately takes place deoxyhemoglobin. That means oxygen carrying capacity will be decreases immediately in our body. So after a few seconds we are inhaling like the methane gas only, the first person will be faint or sometimes it will be die also. This is a case of the methane gas. This is about the general properties of or physical properties of the your alkanes. Now coming to the chemical properties. Already I told that chemical properties, they do not react under ordinary condition for any reagent. For under drastic condition only, these particularly hydrocarbons, saturated hydrocarbons undergo chemical reaction. Particularly first chemical reactions are, only one is important in the chemical reaction, but I will give one more is also, that is called as oxidation. What do you mean by the oxidation? Oxidation means presence of oxygen. That's all. When the gases, that means hydrocarbon, methane, is combusted, means we are firing. That is a combustion takes place. This methane on combustion, what happened? We are getting off carbon dioxide and water. Some amount of energy will be liberated. Or ethane you take C2H6. When you combusted, formation of carbon dioxide, water, and energy is present. Here energy is a 240 kilocalories of energy liberated. Here 740 kilocalories of energy will be liberated. Depending on the hydrocarbons, increasing of hydrocarbon, energy increases more and more. That's why these gases are present in the your LPG gas. See, ethane is getting off 740. Methane, if you are burning off methane, you are getting off 218 kilocalories. I have written there 240, but nearly 218 kilocalories are obtained. This is about the 728. Just approximately, sometimes it is increases. I have written as a 740. So this is a gas, means number of carbon atoms are increases, means the energy will be increases. Just by in our LPG gas, the propane and the butane is major is present than the methane and ethane. So that you are, when you are ignited your LPG gas, the energy will be coming out. You are cooking off your food, and also liberating of what? Carbon dioxide and water is liberated from that one. So from the hydrocarbons. This is about the first oxidation method of the chemical properties. This is under drastic condition only. You are eating with high eating. That means under the you are getting of this particular drastic condition only. This oxidation takes place. And the second reaction, particularly halogenation of hydrocarbons. Halogenation. This is a very, very important. Halogenation of methane. They will ask separate question for this one. Separate 5 marks bit. What is the halogenation of methane or saturated hydrocarbons? Halogenation means under normal condition, methane does not participate in any halogenated reaction. That means chlorination, bromination, it does not take place. But under dark place, in presence of sunlight. So under dark place, methane does not react with the chlorine. But under presence of sunlight, methane is reacted with the chlorine only. This is a condition. This is called as a drastic condition. Dark place, methane does not react with the any halogens, either chlorine or bromine. But in the presence of sunlight, chlorine only reacted with the methane, formation of a chain mechanism. It is a free radical mechanism is obtained. What is the free radical mechanism? What is that called? So if you see that methane, this methane means here you are writing of methane is reacted with the chlorine. This is a chlorine gas. Under normal condition, it does not react it, but under the presence of sunlight, in presence of sunlight only, this chlorination takes place, formation of CH3Cl. This is called as methyl chloride. The
HCl.
first step, methyl chloride and HCl is liberated. This methyl chloride does not stop the reaction. Again, this methyl chloride is reacted with the chlorine that is present in the chemical reaction in presence of sunlight. Sunlight I am using of H nu is nothing but representation of sunlight. Okay. Again, this is called as you are getting off one more HCl is liberated out. This is methylidine dichloride. It is called as methylidine dichloride. Plus HCl. Here also a reaction does not stop. This methylidine dichloride again reacted with the chlorine in presence of sunlight. Formation of CHCl3. CHCl3 is a formula is very important again. CHCl3 is called as chloroform. HCl is formed. This chloroform again does not stop. Again it is reacted with the chlorine gas. Formation in the presence of sunlight, formation of CCl4. This is called as carbon tetrachloride. Carbon tetrachloride. It is a laboratory reagent. You see that these both are the laboratory reagent, chloroform as well as the carbon tetrachloride are the laboratory reagent which are used in the laboratory purpose. So it is very important. Why this is the mechanism is called as a chain reaction. Why chain reaction? It does not stop. Where it stops? Once hydrogen is completely exhausted, then only the reaction will be stopped. See, CCl4 does not having the hydrogen. The reaction will be stopped. Before that, chloroform, one hydrogen is there. So easily removed by the hydrogen by means of the one Cl. HCl is removed out. Okay. Here also, you are removing of one HCl, getting off carbon tetrachloride and HCl is there. See friends, here the chloroform. It is preserved in the brown bottles, but the carbon tetrachloride is preserved in the white bottles. Why? In the laboratory, if you go to the laboratory, you will get the reagent, both chloroform as well as the carbon tetrachloride. Why? Because if the chloroform is exposed into sunlight, what do you get? Ultimately, carbon tetrachloride only. So, avoid the exposure of the sunlight. You are keeping this particular chloroform in the brown bottles. Very thick brown bottles we are using to does not allow the sunlight inside. If the sunlight is allowed inside means ultimately chloroform will be transferred to the carbon tetrachloride only within few hours. So that's why the laboratory reagent it is preserved in the brown colored bottle only. So this is the mechanism which is involved in the chain mechanism. It is a and also free radical mechanism. Chain and free radical mechanism. This is. You have to write it is an important chemical property in the saturated hydrocarbons, halogenation of methane, halogen of hydrocarbons. This will be number of 4 steps are there. I will write also mechanism. What is the mechanism is involved. So in the particularly organic reactions, the reactions consisting of 3 steps. One step is called as the first initiation step. That means when chemical reactions are occurring, the first step is called as initiation. That is you are getting of the first step is called as a initiation. What is the initiation means? It is called as a particularly chain initiation step. First step is called chain initiate will be taken. Initiate means they are ready to react. First step is called as initiation step. Second step means in that how many possibility of free radical will be forming. How many types of possibility. That is called as a propagation. Propagation means widening. Next last step is called as a termination. Termination means end product. End product is a carbon tetrachloride. This is called as a termination step. Okay friends. So in that mechanism, halogenation of methane, the mechanism is like this. What is the initiation step means? Mechanism, I will writing of mechanism. First step, that means chlorine. Chlorine will be formation of free radical. This is the initiation step. First step it is called as in the chemical reaction. Second, this initiation step particularly, that means you are having of methyl chloride is there. Or methane, first we will take the methane. So methane is the free radical will be takes place this formation of HCl and methyl free radical. This methyl free radical will be again treated with this chlorine radical, formation of methyl chloride. Okay, so methyl free radical, again methyl free radical will take place. We are getting off ethane also. These are the possibility of the propagation steps. The propagation steps is nothing but number of possibility is there. How many number of possibility? This is the possibility is there. HCl is formed, methyl free radical. Free radical means a lone electron. This is the lone electron. It is a lone electron. When the lone electron, and also you are getting off chlorine free radical plus chlorine free radical, formation of chlorine only. That's why in the number of steps the chlorine will be presented. This is all the steps are called as propagation step. This is called as a between step, in between step, initial step, in between step. Next, third step is called as the termination step. That is a third step is also called as a termination step. Termination step, you are getting off all the free radical will be getting off. You are getting off. That means carbon tetrachloride, or free radical means methyl free radical. You are getting off methyl chloride. It will be goes on increases. That means chlorination takes place. This is called as a termination step. Termination means end. They are getting. These are the mechanism. Here in this case, what my point is, the free radical is formed. That's why this chain mechanism is involved in the free radical mechanism. Free radical means a lone pair electron. That means not paired electron. Only single odd electron is present on the particular atom. Single odd electron. That is called as a free radical mechanism. Even though it is a chain mechanism. Already I saw that one in the reaction mechanism. Why? Because methane is reacted with the chlorine in presence of sunlight. You are getting off methyl chloride. Again, methyl chloride is reacted with the chlorine, formation of methylene dichloride. Methylene dichloride again reacted with the chlorine, formation of the chloroform. Chloroform again reacted with the chlorine, formation of carbon tetrachloride. These are the present. So, in the mechanism, we are having in each organic reactions consisting of the three steps. One is called as the initiation step. Second is the propagation step. Another third is the termination step. This is about the viewers' preparation of alkanes and the properties. Preparation of alkanes and the properties. You are know that one in this chapter only. One more topic also given. The topic is we are having of the topic in this particularly cycloalkanes. What are the cycloalkanes? How can you prepare the cycloalkanes? That is also important in your examination point of view. So, what are the cycloalkanes? If you see, I will go to the fast. 10 minutes only left for me. 10-15 minutes. Okay. Next topic in this second unit only, that is called as cycloalkanes. What do you mean by the cycloalkanes? Already we know that cyclo means closed form. Alkane means saturated hydrocarbon. The saturated hydrocarbons are in the closed form is called as cycloalkane simply. The saturated hydrocarbons are in the ring form. Carbon atoms are not in a straight form. It is in the ring form is called as a cycloalkanes. Let us take some example. Simple member. The first member in the cycloalkane is cyclopropane. That means minimum number of carbon atoms in the cyclo series is 3. Minimum is 3. Maximum whatever you want. Minimum is 3. See, I am writing off cycloalkanes. This is CH2. 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 It is in a closed form. Sir, why I am writing of CH2 means this carbon is having of 2 bonds only, single bonds. But every carbon is having of 4 covalent bonds. The 2 more bonds with the help of this one. That's why this CH2 can be write as this one. Like that. But it will be not that much of sugar. That's why I am writing in form of CH2. For good looking purpose only. It is called as, how many number of carbon atoms are there? 3. Means prop. It is a root word. Primary suffix is ane. Secondary suffix is not there. But prefix is there. What is the prefix? It is in the closed form. That is called as cyclo. It is called as a cyclopropane. Understood? I know the nomenclature. Root word, primary suffix, and here prefix is there. Prefix is the cyclopropane. So in the next onwards, this cyclopropane, I don't want to write all the carbon hydrogen. Simply I can write the cyclopropane as, what is this? Delta. If I am writing the delta means, sometimes in the arrow mark delta means it is a combustion, eating. But here if I am writing this delta means it is nothing but cyclopropane. Please understand. So this triangle is nothing but, you can remember it is as a cyclopropane. Similar manner, I can write. See friends, here number of carbons are 4, means but. It is a saturated butane. It is in cyclic form, so it is called as cyclobutane. So in the next word onwards, I can write this is cyclobutane is a square. Okay. Now, see friends here, how many number of carbon? 5. Pent. And it is in cycloform, cyclopentane. So cyclopentane I can represent as your hut. Okay. House like model, the hut model. Okay. Cyclopropane, cyclobutane, cyclopentane. You can also write how many number you want, you can write it. See, this is cyclohexane, cycloheptane, cyclooctane, whatever you want. This is the structure you can representing. These all are called as cycloalkanes. So please remember the cycloalkanes from the starting point. Starting member, first family member is propane, cyclopropane, hexane, heptane, octane, nonane, whatever you want. Here, this is a number. So this general formula of cycloalkanes is CnH2n. Don't confuse it. This is actually the general formula of the CnH2n is alkenes. Alkenes. Here also same formula. See, N is equal 3. N is equal 3 means C3H6, C3H6. So cycloalkanes formula also CnH2n, please remember. It is similar to the alkenes actually. But these are the not unsaturated hydrocarbons. These are the saturated hydrocarbons only. These are only the saturated hydrocarbons. That's why please remember the saturated hydrocarbons consisting of a single bond and single bond which is the making of the in cyclic nature. You are getting of the cyclic form. That's why it is called as a cycloalkanes. So friends, here you have to, in this case, preparations. We are taking of the preparations. What are the preparations which are present in the cycloalkanes? Again, the important 10 marks bit. I'll write the very fast preparations. First method is Freund method. Freund's method. What is the Freund method? What are the raw materials which are used in the Freund method? It is nothing but this Freund method also called as internal Woods method. Internal Woods, why are you calling that one? What is the Woods method? Woods method is nothing but, sir, alkyl halide is treated with the sodium metal, sir, formation of higher alkane, sir. Same only here. But here, alkyl halide, not alkyl halide, dihalides are formed. So dihalides, alkyl dihalide, dihaloalkanes. Dihaloalkanes means I will take the dihaloalkanes. Simply we are using of dihaloalkanes. What are the dihaloalkanes? I am taking off the particularly. If you are writing of the dihaloalkanes, please the name of this compound name. Just in the name of I am taking off. This is a straight chain. If you write, how can I write here? See friends, this is the structure actually. I am writing my convenient purpose. Okay, both are. It is a straight chain only. Now the name the compound this one. 1, 2, 3 or 1, 2, 3. at first position as well as the third position. What are the substituents are there? Chlorine. So 1,3-dichloropropane. 1,3-dichloropropane. So this is the name of the compound which are using in the dihaloalkanes. It is called as the dihaloalkanes. I am using. So 1,3-dichloropropane. It is simply called as dihaloalkanes. Generally, I am taking. Okay, these dihaloalkanes are treated in the presence of sodium metal. The sodium metal, already I told that in the alkyl halide, that is the reason why alkyl halide is treated with the sodium metal. So, in presence of that particularly heat, simply this particular dihaloalkane sodium chloride. This is nothing but cyclopropane. This is the Freund's method, very easy method to preparation of. It is called as this Freund method, also called as internal Woods method. Internal Woods reaction. That means the same. It is a alkanes. That is a halides are there, and also in presence of sodium metal. That's why it is preparation of this one. This is a Freund method. You can take any one. This is the first example I am taking that. If you want the butane, you want means you take the instead of the 1,3-dichloropropane, instead of that one 1,4-dichlorobutane. 1,4-dichlorobutane. You are getting off the butane. This is about the Freund method. From this Freund method, you can easily prepare the cycloalkanes. The next is the Pulkins method. So I am writing in the every time in the general method of the preparation of any hydrocarbons, either alkanes or alkenes or alkenes, cycloalkanes, whatever that one. So that you have to write in the examination point of view, 3 methods are compulsory. So in this cycloalkanes, the first method is Freund method, that is nothing but internal Woods method. The second method is Pulkins method. Second method is Pulkins method. Here simply, here some particular raw materials are very different raw materials are present. I will use that particularly. Please name this compound name. You try. These are the two very important raw materials. See this one, you don't write, this is a very biggest one. Try to this one, name of the compound. How many number of carbon atoms? Root word is eth. Carbon, that is the halogen group is present on the first carbon as well as the second carbon. Means 1,2-dibromoethane. 1,2-dibromoethane or ethylene dibromide. This is also called as ethylene dibromide. Simply 1,2-dibromoethane. Now, disodium malonic ester. This is called as a particularly disodium malonic ester. Please remember this one. Disodium malonic ester. This is the ester form. We are getting of COO, C2H.
The voice is
In presence of ethyl alcohol, that is a reagent which is used in that one. Formation of, simply see this one, this dibromide disodium will be formed out, and the formation of CH2, CH2. This C carbon atom, these two are getting off cyclopropane. Cyclopropane. Next, we are getting off sodium bromide. And next, we are getting off carbon dioxide. Next, we are getting off ethyl alcohol. Again, the product 2 moles. This is a Pulkins method, very simple. Only the thing is, you have to remember ethylene dibromide and disodium malonyl ester. These are the two raw materials which are used in the Pulkins method for the preparation of cycloalkanes. Here in this Pulkins method, only you are prepare cyclopropane. But in the Freund method, you can prepare any one. Cyclopropane, cyclobutane, cyclopentane, cyclohexane, whatever one in the Freund method. But the Pulkins method, you can prepare only cyclopropane. Only cyclopropane. Why? Because the disodium malonyl ester, we are having only carbon atom. Here you can getting off this particularly. You are ethylene dibromide. These two raw material you can't change. These two raw materials only reaction with each other, formation of cyclopropane. This is about the Pulkins method. This Pulkins method also very important in the examination point of view. Next, third method, using of the third method is that is reduction. What happened? The reduction process. In this reduction process, you can easily, the benzene is reduced. Reduction means what happened? Adding of hydrogen in presence of catalyst. That is nothing but hydrogenation. Okay. Reduction means here benzene. So the benzene structure, I can write the benzene. Alternative double bond, single bond. This is a benzene. Benzene, you are adding of 3 moles of hydrogen in presence of nickel catalyst, formation of what is this, friends? 1, 2, 3, 4, 5, 6 in the cyclic form means cyclohexane. 3 hydrogens you are adding, simply the bond is broken out, the double bond is broken out, hydrogen will be getting out. This is called as the reduction process. This is the simplest method of preparation of cycloalkane, but in this case also you can prepare only hexane, cyclohexane. In the Pulkins method, cyclopropane. In the reduction process, you can prepare only cyclohexane. But in the Freund's method, you can prepare any of the cycloalkanes. These are the 3 important methods of the preparations of the cycloalkanes. In the examination, these 3 are enough. Freund, Pulkins method, and the next last one is the reduction process. In your book, whatever the manual it is given, please leave it there, all the things. You can confuse. So many number of reactions are there. There's a mechanism like that. It is not, you can properly read out. Okay, this is enough for your examination point of view for the preparations of the cycloalkane. Coming to the properties. Here the properties, physical properties means all the particular cycloalkanes, the cyclopropane and butane is the gaseous state, remaining are the liquid states. Even though, but these are the saturated hydrocarbons. The saturated hydrocarbon means does not undergo chemical reaction with ordinary conditions. So what happened in this particular chemical properties? We'll see the cycloalkanes. Okay. First we see the cycloalkanes properties. First, halogenation. Halogenation means adding of halogens. See, friends, I'm writing. What is this? Triangle. Triangle is nothing but what I told. Cyclopropane. I don't want to write all the carbon and hydrogen atom always. This cyclopropane is reacted with the bromine. The cyclopropane is reacted with the bromine. Formation of simply the chain, that means closed form will be open and formation this one. Please name the compound. 1, 2, 3 at the first position and also third position, there is a halogen is there. 1, 3 dibromo propane. Okay, 1, 3 dibromo propane. Similar manner. This is cyclobutane is reacted with the bromine. Formation of CH2Br, CH2, CH2, CH2Br. So name 1,4 dibromo butane. Very simple. Once you got the first one, this is the only 1,4-dibromobutane. Okay, friends. Suppose if you are taking off next compound, that is the cyclopentane. When the cyclopentane is reacted with the bromine, what happened? If I'll write there on the top, cyclopentane. This is a cyclopentane. Bromination. What do we get? What you are expecting? Cyclopropane is getting, sir, 1,3-dibromobutane. Cyclobutane is getting, sir, 1,4-dibromobutane. Cyclopentane, you may expect 1,5-dibromopentane, sir. But this reaction does not take place. Even though cyclohexane also. Cyclohexane with the halogens reactions also does not take place. Only propane and butane can undergoing these reactions. Addition reactions. This is called as addition reactions. Why? Because alkanes are undergoing addition reactions only, not substitution reactions. Okay, these addition reactions we are getting off this particularly. Only cyclopropane, this ring form is opening. And cyclobutane, its ring form is opening. But the cyclopentane, cyclohexane, it does not react with the any halogens, does not open the ring form. Please keep in mind. Okay, this is particularly halogenation. Next, if you take off hydrogen halogenation, that with the hydrogen, that means reduction also. You can add up the reduction process. Simple hydrogenation. Second, we'll see that one. With hydrogen, what happened of the cycloalkanes? Same cycloalkane, hydrogen in presence of hydrogen, that means the catalyst is required. So nickel catalyst, simply, what is the name, Amma? This one, please name the name. In presence of this one, what is the name? This is cyclopropane. I don't want to write again. Okay, cyclopropane on hydrogenation, cyclobutane on hydrogenation. You're getting off generally is a normal propane. It is a propane, N propane. It is N butane, normal butane. Okay, but if you take that pentane, pentane hydrogenation does not take place. Hexane hydrogenation does not take place. The reaction, no reactions are there. Only propane and butane we are undergoing. That means what you understand by means of this one, even though with the halogen halide also, halogenation and also hydrogenation, and also you can take as hydrogen halide. Hydrogen halide also, only cyclopropane and cyclobutane can undergoing the reaction. Remaining cyclopentane and cyclohexanes are does not undergoing this particular chemical reaction, but they are undergoing of substitution reactions. Substitution reaction means, suppose if you see the halogenation, the first case in the halogenation, how they are substituted. Substitution reaction. If suppose I am taking off this is the cyclopentane on halogenation, any halogen, simply the ring form does not opens, but it is substituted one. This is called as monohalo cyclopentane. Mono means one halogens. Instead of that one, and remaining one HX hydrogen halide is replaced. Suppose I am taking this is a chlorine. We are getting off chloro. So monochloro cyclopentane and HCl is remained. This is called as a substitution reaction. What you observed by means of this reaction? Please, if you see observing of previous reactions, halogenation with the cycloalkane, that means cyclopropane, cyclobutane. The closed form is open, but the cyclopentane, cyclohexane does not react with that one. But during the substitution reaction, it is substituted as a monochloro substituent. This ring does not opening. This is a reason why it is happening. Only cyclopropane and cyclobutane are undergoing chemical reaction. Why not cyclopentane and cyclohexane or higher cycloalkanes? Why not they are participating in that one addition reactions? That will be explained by the Bayer-Strain theory. So Bayer-Strain theory, again, the very important one, your examination point of view. So in the Cycloalkane series, we are having of 3 essay type questions. One is the preparation of cycloalkanes. Next is the properties in the properties are that is a Bayer-Strain theory. Why the Bayer-Strain theory is put forth? Because why only cyclopropane and cyclobutane can undergoing chemical reaction? Why not cyclopentane and cyclohexane? What is the reason? That is explained by the Bayer-Strain theory. So Bayer-Strain theory, some of the defects is there. That defects is explained by the Saxe-More theory. The defects will be explained by the Saxe-More theory. These two theories are very, very important your examination point of view. So what is the Bayer-Strain theory? What he says that all cycloalkanes are your hexagonal ring structures. Okay, that means it is a arrangement will be present in the closed form. This closed form means already we know that the bond angle of the normal bond angle must be 109 degrees 28 minutes. Saturated hydrocarbons, we are remember the methane or ethane. The carbon, the bond angle is 109 degrees 28 minutes. But if you see the cyclopropane, what is the structure? Cyclopropane is a triangular form. It is a triangular form means what is the bond angle of the particular carbon atom? This particular triangle means this particular bond angle is 60 degrees. But normally the normal saturated hydrocarbons is 109 degrees 28 minutes is there. But this bond angle cyclopropane is 60 degrees. We should take that cyclobutane is 90 degrees. Okay, so cyclopentane is 108 degrees, cyclohexane is 120 degrees is there. These are all different bond angles are there. But normal bond angle is how much? Saturated hydrocarbons is 109 degrees 28 minutes. So it is deviated, some angle stress is there. Angle stress means what? Now you are sitting in the classroom. Actually, the benches are allotted for in the classroom. Each bench you have to allotted only 2 students. You are sitting in the classroom, happily seated. But after the few minutes, after number of students are increases. There is no place. What do you say? Please adjust yourself. Means one more student is added to you. Actually, the seated capacity is only 2 in the bench, but you are adjusted 3. Suppose one more is come, you are adjusted 4. How much you are having of that means you are not comfort. The comfort zone is not there. Your uneasiness here also. Actually, the bond angle of the normal saturated hydrocarbons is 109 degrees 28 minutes. But this bond angle is only 60 degrees. It is always ready to open the chain. When they are seeing when the reaction will be takes place, when the reaction I will be open, otherwise the stress is there. I am like that. How can you sit the 4 members in the bench? You can't write properly also. Allow to student enta irukku కూర్చోవాల్సి వస్తుంది ఈ చేతు వేసి ఇక్కడగా తగులుతుంది అతనికి సో that is the meaning of this one here also. Actually cyclopropane is having up only 60 degrees, but the normal bond angle is 109 degrees. How much it is there? So immediately during of the addition reaction, this cyclopropane is ready to react with the halogens or hydrogens or with the hydrogen alide, immediately opening the chain. If it a straight chain is formed, means it is nothing but 109 degrees 28 minutes. So that is called as, it is a deviated bond angle. That is called as stress, bond angle stress. So that is a stress is deviation of the bond angle. How much it is there? You are calculated by the Bayer-Strain theory. The Bayer is calculated bond angle strain The bond angle strain is how much of each molecule, that is calculated with the help of normal bond angle. First, I am taking of the cyclopropane. This cyclopropane bond angle is 60 degrees, but the bond angle strain, the deviation of the bond angle, how much means it is calculated by means of normal bond angle 109 degrees 28 minutes minus actual bond angle. This is the normal bond angle minus actual bond angle by 2. Means see how much, 109 degrees 28 minutes and 60 degrees means nothing but 49 degrees 28 minutes. 49 degrees 28 minutes difference is divided by 2. It is nothing but 2 2s are 4, 2 4s are 8. 1 degree. 1 degree means 60 seconds. 60 seconds plus 28 seconds, 88 seconds. So 24 degrees, 44 minutes. It is called as bond angle, angle strain. It is called as angle strain. So your cyclopropane is how much of angle strain is there? 24 degrees, 44 minutes of angle strain is there. This angle strain, to remove that one, they are easily ready to go with the reaction with the chlorination or with the halogenation, halogen halide, or with the hydrogenation. That's why chain is opening. Similarly, we are taking as cyclobutane. Suppose if you take this is a 90 degrees. See how to calculate? The normal bond angle is 109 degrees 28 minutes. Actual bond angle is 90 degrees. Divided into, that is the average one. So you are getting off what? 109 means this is a how much? 10 plus 9, 19 degrees 28 minutes. 19 degrees 28 minutes means what? It is a 2 9s are okay. 18, 9 degrees, 1 degree is there. 1 degree means 60 minutes. 88, 9 degrees 44 minutes means 60 plus 28. Total 88. 88 divided by this one. I am getting off this one. Don't confuse here. This is 9. That means cyclopropane is maximum bond angle is there. Angle strain is there. 24 degrees. Cyclobutane is 9 degrees 44 minutes. Let us see the third one. Cyclopentane. This cyclopentane is the bond angle. Now actual bond angle is 108 degrees. So 109 degrees 28 minutes minus 108 degrees divided by 2. Okay. So how much you left? 1 degree 28 minutes by divided by 2. That means 0.88 means 44 minutes only. See the bond angle strain. Where is calculated bond angle strain? With the help of the normal bond angle and actual bond angle. Actual bond angle is like that. Normal bond angle is this one. So this particular cyclopropane is the maximum 24 degrees 44 minutes of the angle strain is there. Than the butane, it is 9 degrees. See, pentane almost all negligible, 0. That's why cyclopentane does not participating in addition reaction with the halogenation or hydrogenation or hydrogen halide. Let us see the cyclohexane also. Let us see the cyclohexane. What is the cyclohexane? This is the cyclohexane. The bond angle is 120. So calculate the angle strain. 109 degrees 28 minutes minus 120 degrees by 2 means 10 degrees. 110, you can actually, it is a 110, 120 minus 10 degrees. 10 degrees, remaining minutes are there. I taken as this is the 110. This means here we are adding up 32 minutes are there. 32 minutes means it is nothing but 32 is divided by the 2 means it is a 16. 10 degrees, 16 minutes. Minus, it is not a matter. It angle strain is the 10 degrees, 16 minutes is there. Okay. Sorry. Are you correct or not? This is sorry. Why? Because the difference is right. 10 degrees, 32 minutes divided by 2, right? Divided by means it is nothing but minus 5 degrees 16 minutes. The bond angle strain of the cyclohexane is 5 degrees 16 minutes, means it also chances to undergoing the addition reaction, but it is does not undergoing this particular one, cyclohexane. Coming to the cycloheptane. I'm taking off cycloheptane. See friend, this is about the cycloheptane. I'm using up 7 bonds. Okay. These are the 1, 2, 3, 4, 5, 6, 7. Cycloheptane. This bond angle is 129 degrees. So calculate that one. 109 degrees 28 minutes minus 129 degrees by 2. So it is 110 already. So 110 means remaining 29, 19. Minus 19 degrees 32 seconds divided by 2. Okay. So it is nothing but 2 9s are 18. 1 degree. 1 degree means 60 minutes. 60 plus 32. 92. Okay. 92 means 46 minutes divided by 2. 46 minutes. See this one. Almost all. Cycloheptane bond angle strain is equal to the cyclobutane. This is 9 degrees 44 minutes. It is 9 degrees 46 minutes. That's all. But these are not undergoing any chemical reaction. Only cyclopropane, cyclobutane are undergoing in addition reaction. They are opening the chain to removing the strain, whatever the strain is present. To easily means you have to comfortness they are obtaining by reacting with the chlorine or reacting with the hydrogen or reacting with the HCl, hydrogen chloride. But these particular cyclopentane, hexane, heptane does not react with the any addition reaction, but they are undergoing with the substitution reaction. This is explained by the Bayer strain theory. So why they are not undergoing means that does not explain. Bayer is not explained. Why? If it is a bond angle, okay, cyclopentane is not having the bond angle. It is negligible. We'll write Bayer. Okay, we write. What about the pentane, hexane? What about the heptane? Hexane is having of the angle strain is there 5 degrees. Heptane is having the almost all butane bond angle strain is there 9 degrees is there. It can undergo now, but Bayer is not explain this one. Why they now do not undergoing? That is a reason why this is a defect of the Bayer strain theory. This defect is rectified by the Saxe-Maury theory. We'll leave the okay. Tomorrow we can discuss about the Saxe-Maury theory. Already 20 minutes over, more than my time. Okay. Tomorrow we'll discuss the Saxe-Maury theory. In the Saxe-Maury theory, they explained with the cyclohexane why they do not undergoing that one. What is the conformation? What is the injunction and conformations are there? The two are there. Chair form is there, board form is there. In that board form, chair form, which is the more stable form, that's why they do not undergoing that one. They explained by the Saxe-Maury theory. Then after we will discuss about the alkenes and also alkadienes. That is the two topics are there in the organic part. So tomorrow we'll finish up the organic. We'll enter into the third block, that is the atomic structure also as well as. And one more important point is my suggestion will be here. You are discussing whatever the doubts are there, you are raising. I'm explaining in the classroom itself. Why? Because most of they are having the doubts clear. But think about one few of the students are asking about the science and technology important questions and gender sciences, sir. Sir, you are having of the plenty of the time is there. From the May 7th onwards, we are having the examination schedule is came. So after the my finishing of my classes, that means today and tomorrow, next 5th, 6th March is there. 5th, 6th March, by that 2 more, that means 3 more classes are there. After the finishing of my online classes, I will be kept in your whatever the WhatsApp group, science and technology important questions. Don't worry about regarding of that one. Okay, right, friends?
Sir, important questions for chemistry, sir.
Sorry, ma?
Sir, important questions, sir.
Why do you want the important questions, Amma? I am saying in the chapter wise what are the important. Again, you want the important questions again? Is it?
Sir, how many? Sir,
Okay,
how many
fine.
marks is given, sir? Organic
Okay,
chemistry.
fine. Okay, I'm always saying which is the long question, which is a short bit is coming in the appear in the examination. Even though you can make it as a star marks. And lastly, and we won't expect in the class regular, that means on the online class, I will keep the PPT in your WhatsApp group. Okay, fine.
Sir, how
That's
many marks
why,
is
because
given, sir, in
time is
organic chemistry?
very precious, Amma. We are having only 3 more hours to complete remaining 2.5 blocks. Please, why? Because tomorrow I will finish the organic part. Till 2 more blocks are there. Atomic structure 192, gas state, periodic table, molecular orbital theory, chemical bond. These are to finish it within the 2 hours. Is it possible for me?
Sir,
So
can you send your WhatsApp number, sir?
Already given number, na? So many are
Sir,
there joined in that group.
Sir, I don't know, sir. I joined today only actually class.
Today you are the newcomer. Okay.
Yes, sir.
Already
I
your
came.
friends
I
are there.
joined
They
from
are create,
Vizag, sir.
your friends are created your WhatsApp group. In that you join that one. And my number is already given. So take the number 988-577-214. You request that one. I will send the link, that particular WhatsApp link. I will send to you. Okay.
Okay,
Fine.
Sir, how
thank you,
many
sir.
marks is given, sir, in
Sir,
organic
how
chemistry?
can we get model papers, sir?
What is the necessity of the model paper, Sama? It is not enough for my class. If the model papers is required, means no need to attend my classes, Amma. This is a humble request for me. I'm not this much of strain I'm taking to deliver all the topics. I'm covered all the topics, every point to you. If again you are asking the model paper, model paper is nothing. It is a totally wrong. Who are writing the model papers, Amma? Illiterate is writing the model papers. They're copying. But so many number of mistakes are in the model paper. You are same dumping into the examination. So that mistakes are, you are repeating and repeating. Your material is beautiful material is there. Again, you are coming to the regular class. What I say in the first hour, in the very first class, if you come in my 10 classes, I will give you 70 to 80% marks to you. Only the listening of my classes. That's all. My intention is. I don't want to suggest any model paper. Please remember in my point of view. I don't want to suggest any model paper. If you want the teacher, that means it's classes, or else you are having a beautiful material is there. Your manual is there. University is providing. Why don't you are wasting your money? That is my intention, Amma.
Sir, how many
Because
marks is
the
given,
teachers,
sir?
myself, won't write in my 25 years career. I don't want to write a model paper. If I am writing means I can earn lakhs of rupees in that way. But I don't want like that. Please listen. Please go through that one. You are having of that one particularly. Okay. So bye. Tomorrow we'll meet you.
Bye, sir.